Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Make sure to stick until the end of the video where I have two bonus problems that are similar to this one which you guys can try to solve. So I have 9 to the power of x is equal to 27. And this may seem like a challenging problem because if you notice, if you take, let's say 9 to the power of 0, right? This is equal to 1. 9 to the power of 1, this is equal to 9. And 9 to the power of 2, this is equal to 81. Meaning, x in this case would be either a fraction or also a decimal. Because it can't be a whole number. Alright, so to solve this, it's actually really simple. 9, this is the same thing as 3 to the power of 2. So now if I replace 9 with 3 to the power of 2, I get 3 to the power of 2 to the power of x is equal to 27. Now, 27, this is equal to 3 to the power of 3. So 27, I'm going to replace with 3 to the power of 3. So now I have 3 to the power of 2 to the power of x is equal to 3 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2 times x. It's equal to 3 to the power of 3. And 3 to the power of 2 times x, that's the same thing as 3 to the power of 2x. So equal to 3 to the power of 3. Now, if you notice, both of these have the same basis. Both of these bases are 3. And if I have something in the form a to the power of a is equal to b to the power of b, so this means that If I have something in the form a to the power of a is equal to a to the power of b, this means that if I have something in the form a to the power of c is equal to b to the power of m, this means that c is equal to m. So in this case, 2x is equal to 3. Now to solve this, simply divide both sides by 2. These two cancel out, and I'm left with x is equal to 3 over 2. Alright, so now to check, our original equation was 9 to the power of x is equal to 27. Now x is 3 over 2, so I have 9 to the power of 3 over 2 is equal to 27. Now, 9 again is the same thing as 3 squared, so I have 3 squared to the power of 3 over 2 is equal to 27. Now I have 3 to the power of 2 times 3 over 2 is equal to 27. These two cancel out, so I'm left with 3 to the power of 3 is equal to 27, and 3 to the power of 3 is 27. So if 27 is equal to 27, and because this is right, our solution is right as well. Alright, so I have 8 to the power of x is equal to 80. Now, the first thing I'm going to do is 80 here. This is the same thing as 8 times 10. So I'm going to replace 80 with 8 times 10. So now I have 8 to the power of x is equal to 8 times 10. Now I can go ahead and divide both sides by 8. So I have 8 to the power of x over 8 is equal to, these two cancel out, so simply 10. Now 8 here, this is the same thing as 8 to the power of 1. And now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 8 to the power of x over 8 to the power of 1, that's going to equal 8 to the power of x minus 1. This is equal to 10. Now 8 here, this is the same thing as 2 to the power of 3. So if I replace 2 to the power of 3 with 8, I get 2 to the power of 3 to the power of x minus 1 is equal to 10. And now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, that's going to equal 2 to the power of 3 times x minus 1. And now I can distribute the 3. 3 times x is 3x. And 3 times negative 1 is negative 3 is equal to 10. Now, if I take the log on both sides, I have log 2 to the power of 3x minus 3 is equal to log 10. Now, an important property of logarithms is that if I have log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. So in this case, I can move this to the front, so I'll have 3x minus 3 times log 2 is equal to log 10. Now I can divide both sides by log 2. So then these two cancel out, and I'm left with 3x minus 3 is equal to log 10 over log 2. Now log 10, this is the same thing as 1. So now I have 3x minus 3 is equal to 1 over log 2. And now I'm going to rewrite this as, well, first off, log 2 here, this is equal to 0.301. So now I have 3x minus 3 is equal to 1 over 0.301. Now 1 divided by 0.301, that is actually going to be 3.3223. Now if I add 3 on both sides, I get 3x is equal to 6.3223. Now I can divide by 3 on both sides, and I get x is equal to 2.1074. Alright, so I have 6 to the power of x is equal to 12. Now I want to find the value of x. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 6 to the power of x is equal to log 12. Now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is equal to b times log a. So log 6 to the power of x, I can actually move this to the front. So I'll have x times log 6 is equal to log 12. And now what I'm going to do is I'm going to divide by log 6 on both sides. So now these two cancel out, and I'll be left with x is equal to log 12 over log 6. So now log 12, this is the same thing as log 6 times 2. Now I have this over log 6. Now if I have something in the form log a times b, this is equal to log a plus log b. So log 6 times 2, that's going to equal log 6 plus log 2. I have this over log 6. Now this is the same thing as log 6 over log 6 plus log 2 over log 6. So now these two cancel out, and I'm left with x is equal to 1 plus log 2 over log 6. I'm going to again change to log 2 times 3. Now I have x is equal to 1 plus log 2 over log 2 plus log 3. Now log 2, this is equal to 0.301. And log 3, this is equal to 0.4771. So now I have x is equal to 1 plus 0.301 over 0.301 plus 0.4771. So now I have x is equal to 1 plus 0.301 over 0.7781. Now I have x is equal to 1 plus 0.3868. So x is equal to 1.3868. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4x squared over 16 to the power of x equals 64. Now, 16 is the same thing as 4 squared. So I'm actually going to replace 16 over here with 4 squared. So we have 4 squared to the power of x, and we have 4 to the power of x squared as our numerator. And 64, well, this is actually equal to 4 to the power of 3. So now, as you can see, all our terms are of the same base. We have terms that are all have bases of 4. So now, if we have something in the form a to the power of m to the power of n, this is actually the same thing as a to the power of m times n. Meaning 4 to the power of 2 to the power of x, this is the same thing as 4 to the power of 2 times x, or also known as 4 to the power of 2x. And our numerator is 4 to the power of x squared still. Now, if we have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of m minus n. So 4 to the power of x squared over 4 to the power of 2x, this is the same thing as 4 to the power of x squared minus 2x. And this is equal to 4 to the power of 3. Now, because these two terms have the same bases, then that also means that our exponents here, these two are the same as well, meaning x squared minus 2x is equal to 3. So now if I subtract 3 on both sides, I get x squared minus 2x minus 3 is equal to 0. So now, as you see, we have a simple quadratic equation. So I'm actually going to plug this into the quadratic formula. So negative b, well, b is negative 2, so negative of negative 2 is positive 2 plus or minus the square root of b squared, so negative 2 squared, which is 4, minus 4 times a is 1 times c is negative 3. Now, negative 4 times 1 is negative 4, and negative 4 times negative 3 is positive 12. So we have 4 plus 12, which is 16, and the square root of 16 is 4. So we have 2 plus or minus 4. And we are going to divide this by 2a. So a is 1, so we're dividing this by 2 times 1, which is 2. Now this gives us two equations, or two expressions, 2 plus 4 over 2. 2 plus 4 is 6, 6 divided by 2 is 3. So this is one solution. And we also have 2 minus 4 over 2. 2 minus 4 is negative 2. Negative 2 over 2 is negative 1. So negative 1 would also be another solution. So these are our two solutions to this problem.